Welcome! In this video, we'll look at binary classification, where a model answers a yes or no question, like, does this person have diabetes? We'll use the Pima Indians Diabetes dataset, which includes health details like blood pressure and glucose levels, to predict if someone is diabetic. So let's get started. Alright, so let's take a look at this blue S-shaped curve called the sigmoid function. It takes all of our input features, combines them into a value, z, and then converts it into a probability between 0 and 1. So if you look at this red dashed line at 0.5, that's our decision boundary. If the probability is above 0.5, we predict yes. If it's below 0.5, we predict no. So instead of the hard rules, we're making smart decisions based on probability. Now let's load the Pima Indians Diabetes database and set up the column names for ease of use. First, we'll download and load the dataset and import pandas. Next, we'll load the dataset, and there you'll have our column names. So here now you can see the first 5 rows of our data set. We have features like pregnancies, glucose, blood pressure, and more. And then the rightmost column outcome is our target variable, and that's where 1 indicates diabetes and 0 indicates no diabetes. We'll use PyPlot and Seaborn to visualize the distribution of our target variable. So we'll create a count plot of our target variable. And you can see with the S&S count plot, X equals our outcome and data equals diabetes. So this count plot shows our data set has about 500 patients without diabetes and about 268 with diabetes, giving us an approximately 65% to 35% split between non-diabetic and diabetic patients. Now let's prepare our data and build our logistic regression model. The first part of the code will split our features and target variable. The second part of the code will split the data into training and testing sets. The test set is 0.3, or 30% of the total rows of data. And you can see that in test size equals 0.3. Now let's train our logistic regression model on the training data and then generate predictions on our test data. We'll do this with the logistic regression class from Scikit-learn. You'll notice that the methods such as .fit and .predict are the key methods for training and predicting. So now let's evaluate our model's performance using various methods from Scikit-learn metrics. In particular, we'll use the accuracy score and confusion matrix. First, we're going to need to calculate the accuracy. And next, we'll create a confusion matrix. Now let's check out our results. So our model achieved an accuracy of approximately 75%, meaning it correctly classified about 75% of patients in the test set. This is called a confusion matrix, and it shows our model's predictions in more detail. The darker blue cell in the top left shows 126 true negatives. Patients correctly identified as not having diabetes. The bottom right cell shows 48 true positives. Those are patients correctly identified as having diabetes. The other cells show our errors, 25 false positives and 32 false negatives. So let's examine more detailed metrics with the classification report. The classification report provides precision, recall, and F1 score for each class. You'll see these come repeatedly throughout the rest of this course. For predicting no diabetes, we have 80% precision and 83% recall. For predicting diabetes, we have 66% precision and 60% recall. These metrics help us to understand our model's strengths and weaknesses for each class. Finally, let's see how we use our model to predict for a new patient. So here we have a new patient with specific measurements, including a glucose level of 148, and BMI of 33.6 and other health indicators. We'll make the prediction and then display the result. Our model predicts this patient has diabetes with a probability of 65%. This high probability gives us confidence in the prediction. Okay, so we used logistic regression, and you saw how easy it is to train and get accurate predictions, even without the fine tuning. The same idea can be used for many other yes or no questions too. Let's keep going and build on this foundation.